In the summer of 1908, the Podkamenya Tunguska River in Siberia was one of the most isolated locations on the map. Even today, this stretch of central Siberia remains almost entirely unpopulated. At 7:14 in the morning on June 30th, trader S. Semenov was sitting on his porch 40 miles away when the northern sky tore open. He described a column of blue-white light brighter than the sun, and heat so intense he felt his clothes were catching fire. Then a shockwave threw him from his chair. Reindeer herders much closer to the blast were not as fortunate. Entire herds were incinerated. Encampments were found with metal equipment melted into unrecognizable shapes, and by some accounts, at least 2 or 3 people died. Though in a region this empty, no one can say the true number with certainty. For nights afterward, skies across much of Europe glowed bright enough that people reported being able to read a newspaper outdoors at midnight with no artificial light. A cataclysm of this scale had occurred in the planet's most remote blind spot. It would take decades for the rest of the world to see what happened. When the first observers finally viewed the site, they found 80 million trees snapped at the trunk and laid flat across the landscape. To find something comparable to this level of destruction, you'd have to imagine the entire city of London leveled in a matter of seconds. The explosion is now estimated at up to 30 megatons, potentially 1,000 times more powerful than the atomic bomb dropped on Hiroshima. But the scale wasn't the only problem. Because of the area's remoteness, followed by a world war and the Russian Revolution, a scientific expedition didn't reach the site until 1927, nearly 20 years after the blast. Mineralogist Leonid Kulik expected to find a massive impact crater. Instead, he found only a marshy bog. There were no meteorite fragments, no iron, and no wreckage. The Earth had been hit with the force of a nuclear weapon, yet the object that fired it had vanished without leaving a single trace on the ground. Without a crater to study, Kulik's team mapped the fallen forest. The trees formed a massive butterfly shape, with millions of trunks pointing away from a single point in the sky, like spokes on a wheel. But directly beneath that central point, they found something that contradicted the rest of the site. The trees here were not flattened. These trees remained standing perfectly upright. They were dead, stripped of every branch and all their bark, but they were still on their feet. This detail meant the object never reached the ground. It spent its energy in the atmosphere, several kilometers above the forest. The absence of a crater left room for theories that bordered on science fiction. In the years after Hiroshima, some speculated it was a nuclear detonation. Others suggested it was a piece of antimatter, or even a miniature black hole passing straight through the planet. But the evidence points to a different phenomenon, the airburst. Imagine a stony asteroid, roughly 50 meters wide, hitting the atmosphere at 50,000 miles per hour. As it plunges deeper, the air pressure becomes so extreme it can no longer hold together. It detonates and vaporizes. The shockwave hit the forest from above, stripping the branches off the trees directly below before rebounding and flattening the surrounding miles of forest. This single mechanism accounts for the flattened trees, the glowing skies, and the fact that there was no crater to find 20 years later. Even with modern satellite mapping and soil analysis, we still haven't identified the specific object that crossed 60 million miles of space to strike Siberia. Debate continues over whether it was a dense, stony asteroid or an icier, more fragile comet that would have vaporized even more completely. Researchers have recovered microscopic fragments from the soil, but they are too degraded to provide a definitive identification of the blast source. We understand the physics of how the forest was leveled, but the exact composition and origin of the object remain buried in the Siberian marsh. The legacy of Tunguska is the realization that a space object does not need to hit the ground to erase a city. Earth's own atmosphere can act as a detonator, turning hypervelocity objects into multi-megaton bombs in the sky. It's why astronomers today track near-Earth objects with such precision. They are looking for the next object that matches the profile of the one from 1908. Tunguska serves as a permanent reminder. The sky doesn't need to leave a crater to deliver absolute devastation.